So now we'll talk about concavity, where a function is increasing and decreasing. So by definition, if a function f is differentiable on an open interval, then the function f is said to be concave up, also abbreviated as CU, on the open interval if f prime, meaning the first derivative, is increasing, meaning you have a slope that is gradually increasing, and I'll demonstrate in just a second. If f is said to be concave down on that open interval if the slopes are decreasing, meaning the derivative. Okay, so let's take the first scenario. Here we're saying if the slopes are increasing. So you're not just looking at one, you're looking at the trend of the slopes. So here is my graph that is concave up, like a cup, so it's holding something here. Here, if you notice, your graph, the tangent line is super negative. Okay, then as you continue on, another tangent line, still negative, but getting less. Here, the slope is 0. Then the slope is positive and even more positive. Therefore, your slope is increasing over this period of time. Then they're saying here that the function is said to be concave down, like a frown, if your slopes are decreasing, meaning right here the slopes are super positive, meaning positive, positive, then just positive, then you have a slope of 0, and then all of a sudden the slope goes negative and then super negative. Okay, not negative times negative, but really negative here. So that means the values are decreasing, meaning this could be like 2, 1, 0, negative 1, negative 2. Okay? All right, so with that said, there's another way that we can determine concavity. Here it says let f, meaning our function, be twice differentiable. Now, it doesn't mean that when you are given that statement that you have the second derivative. It means that the first derivative and the second derivative exist, meaning they can be found on an open interval. So they're saying here, if the second derivative is greater than 0, meaning a positive value, okay, then the function itself is considered concave up on that interval. In the next stipulation, it says if you find that the second derivative is less than 0, meaning negative for every value of x in that open interval, then the function is considered concave down over that interval. There you go.